Hi, so for this video, we'll explain what is a converging and what is a diverging lens. Okay, for converging lens, normally it's an oval shape, where the middle, this part, will be thicker, where the top and bottom will be thinner. Okay. Whereas for a diverging lens, the middle will be thinner, where the top and bottom will be thicker. Okay, so some of the names that is used for converging lens, okay, will be called a positive lens or convex lens. Okay, and some of the names that I call for a diverging lens will be called a negative lens or a concave lens. Okay, so later I'll explain why is it called a positive lens and why is it called a negative lens. Okay, but a more common term will be a converging lens and a diverging lens instead of positive and negative lens. Okay, so what is a converging lens and how does it work is that, okay, so I have a converging lens here. Okay, so basically what it does is, this is your principal ray, these are your incident ray. It basically converges the ray into a focal point. Okay, so this is basically what it does. Okay, in your exam you'll need to use a ruler to draw. So now I'm just sketching out the examples. Okay, and this will be your focal point. Okay, whereas for a diverging lens, how it works is that you have a diverging lens. This is your principal ray. Okay, so for all the incident ray, what it basically does is diverge away. Okay, so these are the properties of converging and diverging lens. Okay, so one example you can use in real life is a spectacle. Okay, so for example, this just a normal eye, where this is the iris. Okay, the center of the eye. So in a normal scenario, light ray will pass through your eye, and your focal point should be the back of the eye. But for people with myopia, their focal point is not at the back of the eye, which is somewhere around here. So what does spectacle do is, so this is another eye, this is another eye, this is a lens. So basically what a lens do is that it helps your pupil or the iris, okay, to converge the focal point or converge the light rays to a further focal point, to the back of the eye. Okay, so this is how lenses work. Okay, so in your textbook you will see many examples, like for example there's 8 to 12 examples of converging and diverging lens. But what is more important is you all need to know what is the meaning of virtual image and real image. Okay, and this is how the positive and negative lens come about. Okay, so I will draw here for a positive, for a virtual ray or virtual image. Okay, so for virtual image, normally we will draw it using a diverging lens. So just draw a diverging lens. Okay, so this is your image. Okay, I should draw bigger. Okay, so basically what it does is the ray diverge away. Okay, so how does a virtual image come about? Okay, so we have a principal ray here. Okay, so there's a virtual ray connecting to this diverging ray. somewhere around here. Okay, so the image will appear somewhere over here. Okay, so this will be your image, and this is your object. So the image is normally smaller and is upright. Okay, so anything that is happening in the negative region of the x-axis will be termed as a virtual image. Okay, now for a real image. Okay, so normally real image we will draw using a converging lens. Okay, so I just draw a converging lens here. Okay, so this is your object over here. So basically, here I should copy the. So basically, the ray will converge. Okay, and this will be your focal point. And here to here will be your focal length. Okay, so the image will appear somewhere over here. Let me draw here. Okay, but the image will appear in the positive side of the x-axis. So anything that appear here, we'll term it as real image. So normally the image will be smaller and opposite. Okay, so for this video, it's important to know what's the meaning of converging lens and diverging lens, the term used, what is focal point and what is focal length. Okay, some examples over here, and what's the meaning of real image and virtual image. Okay, so thank you.